Hi students, now we are going to discuss about limit comparison test. Limit comparison test. So this is the test for checking whether the given series is convergent or divergent. First, let us see what is the statement of this limit comparison test. Okay, so first write down statement of this test. Okay, write down statement. Suppose that summation an and summation bn are series with positive terms for all n and L is equal to limit n tends to infinity an by bn. L is equal to limit n tends to infinity an by bn. Okay, first one, if 0 less than L less than infinity, then summation an and summation bn are both converges or both diverges together. Okay, second one, if L is equal to 0 and summation bn converges, then summation an converges. Okay, third one, if L is equal to infinity and summation bn diverges, then summation an diverges. Okay, so this is the statement of this limit comparison test. Okay, so now I will explain about this statement. Okay, listen carefully. Okay, so first of all, suppose we have two positive series. Suppose we have two positive series which are summation an and summation bn, and also we have L is equal to limit n tends to infinity an by bn. Okay, what is L? Limit n tends to infinity an by bn. Okay, so what is the first one? If 0 less than L less than infinity, then summation an, summation bn are both converges or both diverges together. Okay, you observe that here, what is L? L is equal to limit n tends to infinity an by bn. So here we have to find the value of L which is equal to limit n tends to infinity an by bn. Okay, first one, 0 less than L less than infinity, which means that L not equal to 0. First of all, L not equal to 0 and L not equal to infinity. 0 less than L less than infinity means L not equal to 0 and L not equal to infinity. That means L is finite number. L is finite number. Okay, 0 less than L less than infinity, which means that L not equal to 0 and L is finite number. That means L which lies between 0 to infinity. 0 and infinity. Okay, that means L not equal to 0 and L not equal to infinity. That means if limit of an by bn is not equal to 0 and is finite. That means limit of an by bn is not equal to 0 and is finite, then only we will say that both the series summation an and summation bn behaves alike. That means if L not equal to 0 and L is finite, then only we will say that both the series summation n and summation bn are converges, or both the series summation n and summation bn are diverges. Okay, here what is the first one? If L not equal to 0 and L not equal to infinity, means L lies between 0 to 0 and infinity. That means if L not equal to 0 and L is finite number, then only we will say that either both the series summation n and summation bn are convergent, or both the series summation n and summation bn are divergent together. That means if one series is convergent, then other series must be convergent, or if one series is divergent, then other series must be divergent. If one series is divergent, then other series must be divergent. That means L lies between 0 to infinity, except to 0 and infinity, then only we will say that either both the series convergent or both the series divergent. That means if one series is convergent, then other series also convergent, or if one series is divergent, then other series is also divergent. Okay, so this is the first one. Okay, remember that here L not equal to 0 and L not equal to infinity. That means L is finite number except to 0. Okay, in this case either both the series convergence or both the series divergence. That's all. Okay, second one, if L is equal to 0 and summation bn convergence, so then only we will say that summation an convergence. Okay, so what is the second one? L not equal to 0 and summation bn convergence, so then summation an is also convergence. Suppose L is equal to 0 and summation bn divergence, what happen? If L is equal to 0 and summation bn divergence, then in this case we cannot say anything about the series summation an. Okay, third one, if L is equal to infinity and summation bn divergence, then summation an is also divergence. Okay, suppose L is equal to infinity and summation bn convergence, then in this case we cannot say anything about the series summation an. Okay, so here what is L? Limit n tends to infinity an by bn. If L is finite number, then both the series convergent or both the series divergence. Okay, what is the second one? If L is equal to 0 and summation bn convergence, then summation an converges. What is the third one? If L is equal to infinity and summation bn diverges, then summation an is also diverges. Okay, now let us see when to use this test. Suppose summation an is given series. Okay, summation an is given series. First one. Okay, listen carefully. If this series does not involve any powers of x, For example, summation x power n by n square plus 1 is there. Here you see x term is there. Then in this case you cannot choose summation bn. You cannot choose summation bn. That means in this case you cannot apply limit comparison test. Okay. Next, second one, if the given series contain any factorial, for example, like summation 1 by n factorial or n factorial by n plus 1, like this. So here you see it contain what? Factorial. In this case also you cannot choose summation bn. That means in this case also you cannot apply limit comparison test. Next, if the given series, that means if the given series contain repeated series, for example, repeated series is nothing but 1 into 2 into 3 so on n by 3 into 5 into 7 plus so on 2n plus 1 like this. Then in this case also you cannot choose summation bn. That means in this case also you cannot apply limit comparison test. Okay. Finally we can say that if the given series contain x terms or factorial or repeated series, then only we cannot apply limit comparison test. Suppose the given series contain finite powers of n in the numerator and denominator also, then only we can apply limit comparison test. Okay, once again I will explain. Okay, suppose the given series contain finite powers of n in the numerator and also in denominator, then only we can apply limit comparison test. For example, you can see here summation n square plus n plus 1 by n cube plus n plus 2. Okay, can I apply limit comparison test to this series? Yes, you can apply. Okay, next, for example, summation 1 by 2 power n plus 3 power n. Here you see it contain finite powers of n. It contain finite powers of n, 2 power n, 3 power n. So this problem also you can apply limit comparison test. For example, summation 1 by root n sin 1 by n. Okay, like this types of problems you can apply limit comparison test. Okay, so finally we can say that limit comparison test is only possible if numerator in terms of n and denominator is also in terms of n of the series. That should be finite number. And limit comparison test is not possible if it is contain factorial or it is contain x terms or it is contain repeated series. Okay, so here limit comparison test is only possible if numerator in terms of n of the series and denominator is also in terms of n of the series. That should be finite number. Limit comparison test is not possible if it contain x terms, if it is contain factorial and it is contain repeated series. Okay, remember that point. Okay. Okay, write down students how to choose a series summation bn. So here the given series is summation an. Okay, so now let us see how to choose a series summation bn. How to choose a series summation Bn. So here the given series is summation An. Write down. Summation Bn is equal to summation n power capital N by n power capital D. This is D, which is equal to summation 1 by n power capital D minus capital N, where D is the highest power. Write down highest power of denominator in the nth term of summation An, and n is the same highest power of numerator in the nth term of summation An. Okay, so here summation Bn is equal to summation n power capital N by n power capital D. So this is nothing but summation 1 by n power D minus n. So here what is capital D? Highest power of denominator in the nth term of summation An. That means what is D? Highest power of denominator in the series summation An. What is capital N? Highest power of numerator in the series summation An. Okay, here if summation An is given series, listen, if summation An is a given series, it contains powers of n only, then we can find summation Bn. If summation An is given series and it contains powers of n only, then we can find summation Bn. If summation An in the form of fraction, suppose summation An in the form of fraction, then we can take summation Bn as summation n power capital N by n power capital D. So this is nothing but summation 1 by n power D by n. Okay, so this is the formula for choosing another series whenever the given series is a rational polynomial in terms of n only. So this is the formula for finding or for choosing another series whenever the given series is a rational polynomial or rational function in terms of n only. Okay. Now let us see one example. Write down. Use LCT, means limit comparison test, to prove whether the series converges or diverges. First one, summation n square plus 1 by n power 4 plus 4. Okay, as well, like, okay, n square plus 1 by n power 4 plus 4. Now let us check the given series is convergent or divergent by using limit comparison test. So first let us consider the given series as summation An. Therefore An, which is equal to n square plus 1 by n power 4 plus 4. Okay, now we want to choose another series, that is summation Bn. Now we want to choose another series, that is summation Bn. Now let us see how to choose this series. Okay, you observe that here in the given series, numerator of the series summation An in terms of n, and denominator is also in terms of n. You can observe here, numerator of the series is in terms of n and denominator of the series is also in terms of n. Okay, so here for choosing the series summation Bn, so here I am using a formula summation Bn, which is equal to summation 1 by n power d minus n. Okay, so now which is equal summation 1 by n power. So here what is the highest power of denominator in the series summation an. Okay, what is capital N? Highest power in the numerator of the series summation an. So here what is capital D? Highest power of denominator in the series summation an. What is capital N? Highest power of numerator in the series summation an. So now summation 1 by n power. What is the highest power of denominator in the series summation n? So what is the highest power of denominator in the summation or in the series an? 4 minus what is capital N? Highest power of numerator in the series summation n. So what is the highest power of numerator in the series summation an? 2. Okay, so which is equal summation 1 by n square. Therefore Bn which is equal 1 by n square. Okay. After choosing a series summation Bn, just we have to find L is equal limit n tends to infinity an by Bn. Now which is equal limit n tends to infinity. What is an? N square plus 1 by n power 4 plus 4 by what is Bn? 1 by n square. So now which is equal limit n tends to infinity n square plus 1 by n power 4 plus 4 into n square by 1. Already we know that how to find limit of this rational function at infinity. Okay, so now which is equal limit n tends to infinity. Okay, so here in numerator I am taking n square as a common factor. So here we get n square of 1 plus 1 by n square into n square by in denominator also I am taking n power 4. Okay, in denominator I am taking n power 4 as a common factor in denominator. So here we get n power 4 of 1 plus 4 by n power 4. Okay, so here in denominator I am taking n power 4 as a common factor. So here we get n power 4 of 1 plus 4 by n power 4. So here you observe that here n power 4 cancel, n square n power 4 get cancelled. So here we get limit n tends to infinity of 1 plus 1 by n square by 1 plus 4 by n power 4. So next we apply limit n tends to infinity. So here we get 1 plus 1 by infinity by 1 plus 4 by infinity. So which is equal 1 plus 1 by infinity is nothing but 0 by 1 plus 4 by infinity is nothing but 0. So now which is equal 1. Okay, therefore L is equal to 1 which is not equal to 0 and finite. L is equal to 1 which is not equal to 0 and finite. Already we know that if L is finite and not equal to 0, then summation an and summation bn are either convergence or divergence by limit comparison test. Okay, so now let us see. But here write down summation bn what? Summation bn is equal to summation 1 by n square. Summation 1 by n square is convergent by P series test. Since P is equal to 2 which is greater than 1. Already we know that summation 1 by n square is convergent by P series test. Okay. Now by limit comparison test we have summation an and summation bn are both converges, CGS are both diverges together. Okay, but summation bn is convergent by p series test. Okay, already we know that if L is finite and not equal to 0, then either both series convergent or both series divergent, but summation bn is convergent here. Okay, here listen carefully. If L not equal to 0 and L is finite, then either both series convergent or both series divergent. That means if one series is convergent, then other series must be convergent. Okay, if one series is convergent, then other series is convergent when L not equal to 0 and L is finite number. But here summation Bn is convergent by P series test. Therefore, by limit comparison test, we can say that summation An is nothing but summation n square plus 1 by n power 4 plus 1 is also convergent. Okay, if L is finite and L not equal to 0, then either both series convergent or both series divergent. Okay, that means if one series is convergent, then other series must be convergent, or one series is divergent, then other series must be divergent. But here one series, that is summation Bn, is convergent. Therefore, other series, that is summation An, is also convergent by limit comparison test. Okay, so now I will explain one more example. Okay, second one, summation 1 by n square plus 1. Second one, summation 1 by n square plus 1. Okay, so first let us consider the given series as summation An. Therefore, An is equal to 1 by n square plus 1. Okay, so now we want to choose another series, that is summation Bn. Okay, tell me how to choose summation Bn. Summation Bn is nothing but summation 1 by n power d minus n, which is equal to summation 1 by n power. So here what is capital D? The highest power of denominator in the series An. So what is the highest power of denominator in the series? 2 minus n. Capital N is nothing but highest power of numerator in the series An. Okay, so here 0. Hello, here the power of constant term is 0. Okay, so now which is equal to summation 1 by n square. Okay, is nothing but therefore Bn is equal to 1 by n square. So after that we have to find limit. Okay, limit n tends to infinity An by Bn is nothing but capital L. Limit n tends to infinity, An is nothing but 1 by n square plus 1 by Bn. By Bn is nothing but by 1 by n square is nothing but n square by 1. So now which is equal to limit n tends to infinity n square by, so here by taking n square as a common factor in a denominator, so here we get n square of 1 plus 1 by n square. Okay, so here n square get cancelled. So next we apply limit n tends to infinity. So here we get 1 by 1 plus 1 by infinity, which is equal to 1 by 1 plus 0 is equal to 1, which is not equal to 0 and finite. Already we know that limit of An by Bn is not equal to 0 and finite, then only either both series convergent or both series divergent. Okay, by limit comparison test we have summation An and summation Bn are both converges or both diverges together, but summation Bn, which is equal summation 1 by n square, is convergent by P series test, because P is equal to which is greater than 1. Therefore, summation An is also convergent. Summation A is nothing but 1 by n square plus 1 is convergent. Okay, because one series is convergent, then other series must be convergent. Okay, by limit comparison test when L is finite and not equal to 0. So now I will give you some problems corresponding to this topic. Okay, please do it. Okay, next I will explain some more problems corresponding to this topic in the next video also. Okay, so first write down some problems. Next, third one, summation n cube plus n square plus 1 by n square plus 2n plus 5. Okay, so here I will give you answer. So this is divergent. Okay, fourth one, summation 2 root n by n into n square minus 3. So this is convergent. Fifth one, summation 1 by root n plus root of n plus 1. This is divergent. Okay. Sixth one, summation root n by n square plus 1. This is convergent. Seventh one, summation 3n plus 4 by 2n plus 1, 2n plus 3, 2n plus 5. This is also convergent. Okay. In fifth one, first we have to, in fifth one, what is the another function? In fifth one, tell me. Please think. Okay. In fifth one, what is the highest power of denominator? Tell me. Okay, I will give you hint. The highest power of denominator in fifth one is 1 by 2. Okay, 1 by 2. Okay, that means in this case we have to choose another function, another series, which is summation 1 by root n. Okay, take summation bn as 1 by root n in fifth one. Okay, don't confuse.